All right, looks like we're ready to roll here.
All right, you gotta look at this.
I'll look at it later. I promise. Okay, so trig proofs. Now, you guys, we've talked a little bit about, yes, how we're going to do proofs in here and how they're different from the proofs that you guys did in geometry. Basically, if you guys can do what we did in the last section, you can do this. Well, we're still developing those skills a little bit, but in general, okay. What I'm trying to say is what we're doing in this section, really, at the heart of it, is no different from what we were doing in the previous section. Okay. The only real difference is you're going to take your time a little bit more, and you have to justify each step along the way. So you're going to no. So you're going to go through a series of steps. You're going to go through a series of steps to simplify an expression involving trig, okay? And along the way, you have to include why you're doing each one of the steps. No.
Because the note said so.
So.
You said so. How's that one?
No.
No?
Doesn't work now. So let's try one here real quick. So the one difference here, too, is in the setup, you're going to know what the answer is, like what it is when it gets simplified. Like, for example, that equals sine x. Let me zoom that in just a little bit. Hopefully that'll clear it up. Maybe. A little bit more. I don't know. Oh, that's okay. That works. Okay. So, and you might be able to even see the roadmap in your head here. I don't know. About, oh yeah, that equals sine. I can see that. Okay. And that would be, if you guys can follow me here real quick, sine squared plus cosine squared is 1. 1 over cosecant is sine. Right? Because it's a reciprocal of the cosecant makes it sine. Okay. Now, we got to put this into a formal 2-column style proof. Okay. So, the way that we do that is you can't work with both sides of the equation. You take one side of it, and usually the easier way to go is going to be to take the side that looks more complicated and start there and try and get it to the one that is the least complicated, okay? Because we're used to doing that. Simplifying things is kind of a natural thing for us in math. We want to make things simpler, okay? Taking something that's simple and kind of building it up and making it more complicated is very difficult for us to do. So find the part that looks more difficult, sine squared plus cosine squared over cosecant. That's going to be your home base. And then you're going to go from there and try and explain each step of why is this equal to sine. Okay? So in our 2 columns, we have one column that is the statement, and the other column are the reasons. And just like your geometric proofs, step 1 is always given. And the given is the complicated side of the equation. Okay, you are not writing the entire equation as your statement. It's just the one side of it. Okay, because if we can prove through a series of steps that this thing is equal to this next thing and that thing is equal to this next thing, and eventually we get to sine, we've proven that, yes, those two things are equivalent. We have proven that identity up at the top there. Okay, so if you were just to go about simplifying this thing, what would be your first step? What would you change about it? Yeah, Jeff. Okay. Why? It's a Pythagorean identity. So there's your reason. And if you want to abbreviate, that's fine. like Pythag ident, something like that. It's a Pythagorean identity, though, that lets you do that. Okay. What now? Mm-hmm. Yep. And that's a reciprocal identity. Mm-hmm. And that proof's done. So that was a 3-stepper. Okay? So we just went through the series of steps we would have naturally gone through anyway to simplify this thing. And then just over here, we're identifying what were we using to get through each step. Okay? And then I always put a little QED. You guys remember that if you had me. QED stands for Quad Iterat Demonstratium. It's Greek, which means is what we were trying to prove in Greek. But basically it's just a little... You don't have to, no. But some people do. Have you ever seen like the little square? Some people just put the little square at the bottom right to say, hey, I'm done. It's just a stamp that says this is the end of the proof, but you don't need to do it. That would be nice. Okay, so... One. Make this one maybe a little bit more difficult. Oh, you'll see. What? No. It's a 2-day lesson. Okay, let's try this one. We're going to prove that cosine times tangent x plus sine x cotangent x equals sine x plus cosine squared x. All right, so what do you think should be the one we start with? The left-hand side, yeah, for sure. So... Bless you. Okay, so there's your given. Cosine x times tan x plus sine x cotangent x. So, anybody want to help us get started here? What do you think?
Isn't sine x times cotangent x just cosine?
It might be. But why?
Because the note said so.
Here's the thing. For a lot of you, and I think this is probably you, you're going to have to slow down a little bit with these. You're used to jumping through things like, oh yeah, that's a cosine. I'm going to make it a cosine. Okay, well, back up the train a second. How do you know it's a cosine? What did you change and why? And what canceled out and why? You have to go through all of those individual little steps to get there still, okay? So, yes, that equals cosine, but how do we get there? So, can anybody help us out? Where's a place to start to show that? Change what? Correct. Yes, we got to change it to some sines and cosines. Now, We can do more than one thing at the same time as long as it's using the same type of identity. So if we change both tangent and cotangent into sines and cosines, is it using the same identity? What kind of identity is that? Remember the name of those? Quotient. Yeah, quotient identity, right? So, since my reason is quotient identity, I'm going to go ahead and do both, okay? But that's the only time you can do more than one thing. Tangent is sine over cosine. And then cotangent is cosine over sine. All right, so we did a quotient identity to get it to there. Okay, now what? Before we distribute, probably want to do something else. Yeah, so like these two signs right here are going to cancel, right? So that would be a good next step, that cancellation first, before we try to bring the cosine into the mix here. Okay, now that wasn't so much an identity, right? Doing that step, what exactly did we just do there? We multiplied, and then through multiplication we simplified it, right? So ultimately, the reason is going to be multiplication. We just did a multiplication. Okay. Now, the next step is going to be to pull that cosine into the mix, right? And in doing that, I am multiplying, but it's a special kind of multiplication called what? Yeah, it's the distributive property is what we're using there. So if I distribute the cosine, I'm going to get sine x because it'll cancel the cosine on the first one. And then cosine times cosine is cosine squared. And so that'll be the distributive property. Okay, and then we're done, right? We got that original expression, cosine times tangent plus sine cotangent, to simplify down to sine plus cosine squared. And we have a reason for each step along the way. We got it. We're done. All right. So I'm going to turn off the camera. I'm going to give you guys a couple to try on your own. We're going to practice this a little bit. Okay? All right. So some of you guys asked, like, is this all we're doing? Is this it? How is this 2 days or whatever? These are the easy ones. Okay? So we're going to practice some easy ones. These are going to be the ones we're going to practice right now. Okay? We're going to focus on this type today just to kind of get the process down, get used to using the identities the correct way and the proofs and that sort of thing. And then tomorrow we'll get into the little nastier ones that can have some other issues that might pop up. So I want to get this under our belt first before we jump into that stuff, though. So let me turn off the camera then. Okay, I think we're good here. All right, so we're going to start off with this particular proof today. Cotangent squared minus cosine squared equals cosine squared cotangent squared. And we talked yesterday a little bit about how if you see things that are squared, it's worth trying a Pythagorean identity, that sort of thing, and see if that helps out. And so we could have gone that route with this one and tried that and see what happens. But if you notice something else going on, even if that's there, you usually want to kind of take a different route with it. If you notice that you have two terms that are added or subtracted, and it equals a single term of things being multiplied together, usually that implies some sort of common denominator, you got to put two fractions together type of a proof that you want to do. And that 9 times out of 10 will supersede trying to use a Pythagorean identity in there instead. Okay, so that's the route that we're going to take with this one. Okay, so we're going to try and use some common denominators to help us to get through this proof. That being said, you also, remember, you want to choose the side of the equation that looks more complicated. And if you have one that has this kind of a look to it, you're going to want to pick the side that has the addition or subtraction in it to start with. Okay, so that cotangent squared minus cosine squared, that's going to be our given for this one. Okay, so we're going to start with cotangent squared minus cosine squared and see if we can simplify that using some common denominators to get it to be cosine squared, cotangent squared. I'm going to zoom this in just a little bit more so we can see it better. Maybe, in theory. Yeah, okay, that'll work better. Okay, so if our goal is common denominators, where do you suppose I should start this thing here then? Okay, so take that cotangent, rewrite that. So what is a cotangent? Yeah, so in this case it would be cosine squared over sine squared. And what lets us do that? Quotient identity, yep. Okay. So, now what? Remember, we're trying to get common denominators, right? So what do you think? Right. Our common denominator is going to have to be sine squared, right? So the first term is okay. The second term, we're going to have to do some multiplication to get it there. So it's going to be cosine squared x sine squared x over sine squared x. Does that make sense to everybody? Okay, multiply the top and the bottom by the same thing, and then you're okay. And that gives us sine squared for both of them. Now, I talked about this yesterday a little bit. As far as the reason for this, you could just say common denominators, and that's okay. Otherwise, what did I do technically there? Multiply by 1. Right, when you do sine over sine, you're multiplying by 1, and that's okay. So either one. I'm just going to write common denominators, but you could say that too. Okay, so now what? Yeah, put them together now, right? Once you got those common denominators, remember the whole reason for that was so that you could actually subtract the two things into one big fraction. So our next step will be cosine squared x minus cosine squared x sine squared x over sine squared x. And what do you think I should write as my reason for that? Yeah, subtraction. I just subtracted the two. All right, so now I've got the whole big fraction put together, and I somehow have to get this to look like this. Okay? I need it to be a multiplication of two things together. So take a look at what we have there. What might I do next? Yeah.
Factor out the cosine squared x on the top.
Alrighty, sounds good. So here we can do a little bit of factoring to help kind of break things into a multiplication problem there. So if I take cosine squared x, out of that numerator, I'm going to have 1 minus sine squared x. Still all over sine squared x. And your reason for that then would be what? Factoring. Yep. Okay. Anybody see any other identities in the mix there now? Yep, Josh.
Doesn't 1 minus sine squared x turn into
Cosine squared. Yeah, because sine squared plus cosine squared equals 1. So 1 minus sine squared would give you a cosine squared. So, yep, that's what we want to do next here then. And what kind of identity was that? Did we say? Pythagorean? Yep. All right, now it's probably pretty tempting here now to say, okay, I got cosine squared times cosine squared up top. I can actually put those together and make cosine to the 4th x. Okay, but here's a spot where it's important to think about where you're trying to get to. We want to get this thing to be this, right? Cosine squared times cotangent squared. If I multiply those cosine squareds together, I'm going to lose this cosine squared right here that I want. Okay? So I want to rewrite this in a way so that it's cosine squared times something, right? Yeah.
Can you split it up into cosine squared x over 1 times cosine squared x over sine squared x?
You could. Mm-hmm. This would be factoring again, technically. And I'm going to just write it this way. And this is a step that I talked about yesterday a little bit with a proof that somebody came up and showed. I can't remember who it was. Where you don't necessarily have to do this. You could skip over this one and it would be okay. But I'll go ahead and write it down since you guys mentioned it. But that's a factoring thing. It's the next step that's the crucial one, though. Once you have that separated, do you guys see how we can finish this thing up now? Do another quotient rule, right? Take that, or quotient identity. Take that cosine squared over sine squared. That's cotangent, right? So we can put it back. Cosine squared x, cotangent squared x. And then we're done. We got it there. Okay, so that process makes sense all the way through? Okay. Now, it's one thing to watch me do it and have me kind of give you little nudges in the right direction. It's another to take this thing from scratch and do it by yourself. And that's where the challenge is going to be in this, I think, for you guys. There's a lot of places in here where it's, like I said, kind of tempting to go one direction with it, where that might lead you to a roadblock and you got to go and start over again. It's really common to work on these and you go a certain ways into it and then you just got to erase and start over again. Okay? And it can be a little frustrating, but if you kind of think about all these different techniques we've been talking about, and if one thing doesn't work, try another one and see. And there are some kind of trends, like I said, like if you have something where it's an addition or subtraction equal to a multiplication, automatically my brain goes to common denominators. I got to put those two fractions together somehow to make a multiplication. Okay? Stuff like that. If you see the little squares in there, if it's any other situation, try a Pythagorean identity and see if that works. That's not working out, try to put everything into sines and cosines and just see if something presents itself. There's not like one cookie cutter method that works every time for these things. You got to just keep trying different stuff until you get something that works for you. So, and the more you do it, the more you'll be able to kind of anticipate what's going to be needed for each proof as you go through it. So, anywho, okay, let's do one more, and then I will let you guys get after it here. No, not 30, but more than 5, though. I think I don't want to say because I don't remember exactly. All right, so
here's one. This is about as difficult as it's going to get for you. Sometimes you'll see ones that look like this, and it's going to be really difficult to determine which side of the equation to start from.
So, there's a trig identity. Cotangent squared over cosecant x minus 1 equals cotangent x over secant x minus tangent x. They're both fractions. They both have a subtraction in the denominator. One of them is cotangent squared on the top, but the other one's a secant minus a tangent on the bottom rather than a cosecant minus 1. In this case, both are going to be probably about the same. So it doesn't really matter so much which one you choose. Okay. I'm going to just go with using the right side. I'm going to start with the cotangent over secant minus tangent because that's how I did it the last time, and that's what I feel more comfortable showing you. But this one probably would be about the same either way. Okay. So all right, so our statements and reasons here.
So our given, I said I'm going to go with this cotangent x over secant x minus tangent x.
And this is one where, like I said, sometimes like a real clear path doesn't really present itself, and there isn't really a clear what do I do on this one. And whenever I find myself stuck in that situation, that's where I go with the cosines and sines. Just change everything into cosines and sines best you can, and then see if something presents itself from there. Okay, so that's the strategy we're going to take, at least to kind of get this one going. So if we look at what we have here, there are a couple different types of identities that'll get us to that point. What different types of identities are we going to use to get started here? Quotient and what else? Because quotient will take care of the cotangent and the tangent. And we need a reciprocal identity to take care of the secant. Okay, so we're going to do 2 steps to do that. So cotangent is cosine over sine. Still got the secant. Tangent is sine over cosine. Okay, so we're at that stage. And then step 3, we can go ahead and do cosine over sine over 1 over cosine minus sine over cosine. And that's using the reciprocal. Okay, so now comes like the hard part where we got to try and figure something out now. Is there something we can do with this? So anybody notice anything we might be able to pull off next here? Yep. Yeah, if you notice those fractions on the bottom there, they have the same denominator, right? So we could pull those 2 fractions together and see if that helps us out here at all. So let's go ahead and do that. So in our step 4 here, we'll have cosine x over sine x on top. And then we've got 1 minus sine x over cosine x on the bottom. And what did I do there? Subtraction. Yep. All right, so that got us to there. We're still in a place where we feel like we might be kind of stuck. Anybody have any ideas what we could do? I can help you out if not, but yeah. Oh. Yeah. So we got a fraction divided by a fraction, so turn that into a big multiplication of fractions instead. That usually helps out. Is that what you were going to say, Madison? Or were you thinking something else?
The 1 minus sine,
Mm-hmm. Good try. It's not squared though, right? 1 minus sine squared would give us cosine squared. And that's actually a common mistake that a lot of students make. They think about that Pythagorean identity and 1 minus sine must be cosine, but it's only if it's squared. Yeah, you can do that. So we'll go ahead and do the fraction flip thing here. So cosine x over sine x, and now multiplied by cosine x over 1 minus sine x. And for that one, just going to make this multiply by reciprocal. Or just multiply recip. Something like that, because that's an okay thing to do mathematically, and you're not really changing the value of anything, so that can be an okay reason. Okay, so then from there, we got to actually multiply the stuff together, right? Let's see what we get. So we'll have cosine squared x on top over sine x minus sine squared x. Okay, so we're kind of sort of getting somewhere, right? We've got a single term on top that's squared. We're looking for cotangent, so we're getting there. It's a cosine, not a cotangent, but we can make that work. And that was just a multiplication. I guess distributive property if you want to get technical with the denominator there, but if you just write multiply, that's fine. So, okay. So, we got a cosine squared on top. I want to make it cotangent squared. What can I do to cosine squared to turn it into a cotangent squared? Yeah.
there's the sine squared on the bottom, so you can simplify that into cotangent with your 1 on the bottom.
Nope, we can't actually. I'd have to factor something out of the bottom to put it with the top, right? So if I took a sine, I can't take a sine squared out of the bottom, but I could take a sine out. But then to make it cotangent, don't I need the sine squared technically, right? So I wouldn't be able to do that to pull out a sine squared and then divide it. And remember, you can't just like pick one of the two terms. It's got to be a factor of the denominator, not just a term of the denominator to be able to do that. So good try though. Anybody? Just think in general, like ignoring the problem at hand for just a minute. If I have a cosine squared and I want to turn it into cotangent squared, what do we have to do to it? Divide by sine squared, right? Because cotangent is cosine squared divided by sine squared. So what if what I had in the numerator, cosine squared x, and I multiplied it by a 1 over sine squared? Exactly. Okay, so I'll catch that. I'm doing what I need to do in my numerator to get what I want, but I can't just leave it like that. I have to do it to both the top and the bottom of that fraction. So if I'm going to do that, then I'm going to have to take this sine x minus sine squared x and also multiply it by 1 over sine squared x. So that makes it so I'm actually multiplying the entire fraction by what? By 1, which is okay, right? So you have to do it that way. So this will just say multiplication by 1, because we're multiplying the top and the bottom of that fraction by the same thing. All right, so if we actually multiply, distribute that thing in, okay, we're going to get our cotangent on the top then. And then on the bottom, if I distribute this around, 1 over sine squared times sine, what's that going to leave me with?
just a 1 over sine, not squared anymore, right? Because this sine will cancel one of these two down here. So just a 1 over sine x. And then what's sine squared x times 1 over sine squared x? 1. So that will just be a multiply. Okay, we're really close, right? We're trying to get cotangent squared over cosecant minus 1. What? Right, just turn that into a cosecant, we're done. Got it. Up top? Cosine squared times 1 over sine squared?
Yeah, but in step 8,
Yeah?
cotangent squared, I thought we were trying to get the cotangent.
Cotangent squared. Because we're trying to get it to be this.
Oh, wow.
Right? Oh, okay. Okay, so step 9, we can finish it up. Cotangent squared over cosecant x minus 1. And that was a reciprocal identity, right? To finish that up. All right, and that's it. All right, that's, like I said, that's about as bad as it gets. Okay? There's a lot going on there, and we had to get a little tricky in the middle there, multiplying by the 1 over sine squared and 1 over sine squared. Okay? So if you're getting yourself in a situation where you're stuck, trying something like this is not always a bad idea. That can get you unstuck sometimes too. And it just kind of depends on where you're at. But and every problem is different. So hopefully those two examples today kind of helped you out a little bit. But like I said, I wanted to give you guys a lot of time to just work at the stuff and just see how it goes. So that's what we'll do next.